Okay, hi everybody, welcome back to this channel. Thank you very much for joining me once again. If you're new to the channel, guys, please make sure that you are subscribed, turn on that notification bell so that you can be notified every time when we upload a new session. Okay, so today we're going to be continuing with revising past trial exam papers, and today we're going to look at the 2024 pre-trial exam paper from the Limpopo province. Okay, so we're gonna look at a section on counting principle. Without wasting any time, let's get straight to it. Okay, so we are given cards, right? These are cards that have letters in them, and you can see it's forming the word mathematics there. So the first question is saying how many other words can be arranged using all these cards, right? So you have different cards and you can see on the cards there are letters, right? If you put them together like that, in that order though for mathematics. Now the question is saying how many other words, right? This is very important, guys. The word other words, it means excluding this one, mathematics. How many others can you form using the letters of this card? Okay, so obviously we have to first count how many words are there, right? I mean letters are there. So we have 1 2 3 4 5 6 7 8 9 10 11. Okay, so you know that in counting principle, if I have 11 different items, they can be arranged in what? In 11 factorial ways, right? But in this case, guys, some of the letters are repeating. It means to cancel out the effect of counting the repeating one as different. Therefore, we need to divide by the factorial of the repeating letters. Let's first check which ones are repeating. Okay, so you can see M, it's a repeating, right? So M is a repeating 2 times. And we can see A as well. It's a repeating what? 2 times. And we can see T. Can you see T? It's also repeating 2 times, right? Yeah, there's nothing that is repeating. So in total, we have how many? We have 11 letters, right? In total, where M is repeating 2 times, A is repeating 2 times, T is repeating 2 times. Maybe let me use a different color. Okay, so the total number of arrangements that can be formed, it will be 11 factorial. Do not forget, we need to divide by the factorial of the repeating letter to cancel out the idea of counting the similar letters as different, right? We do recognize there are some that are repeating. So to remove them from that counting that we're doing, we divide by the factorial, which is M, which is 2 times, A 2 times. So we're going to multiply by 2 factorial and 2 factorial. Okay, so we have to be very careful. They said how many other words. So this is the total words that can be formed, right? But in this one, there is this one called mathematics. And the question is saying how many others. So we need to remove one, removing that one of mathematics so that we can count other words that can be formed. Okay, so we can just punch this on the calculator and get the answer. So it'll be 4989600 minus 1. Then obviously it'll be 4989599 different words that can be formed. Okay, so excluding mathematics, because we subtracted 1 there, so we just needed to be a little bit careful with that. Okay, let's go to the second one. So the second one is saying what is the probability that a word made has all the vowels above next to each other? Okay, so using the letters of this word mathematics, what is the probability that that word that you form, it will have all the vowels together? Okay, so we are going to group all the vowels together. What is our vowel? A is our vowel. We have 2 of them, right? E is a vowel. It's only one of it. and we have I. Okay, so those are the only vowels that we have. Then you have your M, T, H, M, T, C, S. Okay, outside. So if all the vowels are together, we're gonna treat them as one unit, guys, right? Then we count how many different objects are there to arrange, right? So remember, the question wants the probability, not necessarily the number of favorable outcomes or the number of arrangement in this case. And we do know that probability of an event is equals to, in this case, in county, the number of favorable arrangements, right, divided by the total number of arrangements. Okay, so that would be the probability in counting principle. We just said the total number, the number of favorable arrangements, the desired arrangement, that is all the vowels must be together. We're going to count that number of favorable arrangement divided by the total number of arrangements. Okay, so and we can do that. So let us now count the number of favorable arrangements, that is all the vowels must be together. We treat them as one unit. We count, if it's one unit, it's like it's one object, right? We count how many are there to arrange. It's 1, 2, oh sorry about this, 1, 2, 3, let me do this, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so these ones can be arranged. Maybe let me change the color. Maybe, I don't know if this will be visible. So it's 8 different objects, 8 factorial ways. But amongst these, there are some that are repeating, right? You can see M is repeating 2 times. You can see T, it's repeating what? 2 times. So we're going to divide by 2 factorial for the M times 2 factorial for the T. Someone might ask, but say, we have some A's there that are repeating, right? Remember, in this case, when you are treating it as one unit, it's like it's one object. So on the outside of this, so this is like one object. So it's 1, 2, 3, 4, 5, 6, 7, 8. 8 factorial. What are repeating amongst these things? So this is one object. You can't look inside and say some are repeating inside. It's like one unit. You consider it as one unit. So we look, what are some that are repeating? It's M 2 times and it's T that is repeating 2 times. So we divide by those factorial, right? But inside, there are some arrangements that can be made. They can't sit as A. We can arrange them in many different ways. Remember, we have to also multiply by the number of arrangement inside that unit. Okay, so inside the unit, how many letters are there? 1, 2, 3, 4. 4 factorial. But how many are repeating? We have A repeating 2 times. We divide by what? 2 factorial. So that will give us the total number of arrangement when all the vowels are together. Okay, I hope you understand this. Okay, so I'm just going to use my calculator to get the answer of that, which is 8 factorial divided by 2 factorial times 2 factorial multiplied by 4 factorial divided by 2 factorial. Okay, so the answer will be 120,960. Okay, so we have just calculated the number of what? Favorable outcome. Okay, I'm just gonna put it somewhere on top, right? Probability for number 2. So the probability of this event, the number of favorable outcome is 120,960, right? Divided by the total number of arrangements. So the total number of arranging all this letter word, we have already counted it, right? Previous question, right? But remember, the previous one said other words, so it excluded the word mathematics. So in this case, we won't exclude it because we are saying total number of arrangement. So the total number of arrangements is that 11 factorial divided by all the repeating letters in that thing, 2 factorial, 2 factorial, 2 factorial, which gave us what? This one, before we removed that one for maths, because in the first question, the maths one, mathematics one was not needed, but in this question, total number of arrangement will be including that one for mathematics, which is what? Which is 4989599. Okay, so when you simplify this, you'll get your answer as 120,960 divided by 4989599. So it's gonna give me 0.242. If you write this in percentage, 0.242 times 100 is it 0.242? Let me check. 0.0242, 0.0242 times 100, right? So the probability will be 2.42%. Okay, so that will be the probability. Okay guys, I hope you find this helpful. Don't forget to like, share, comment and subscribe. See you soon. Bye.